Hello, I'm Dr. Sunil. Welcome to this revision session on trigonometry for GCSE Higher Math. Before we start off with problem solving, I would like to give you a brief overview of what the concepts are so that we have no doubts or clarifications which may be necessary, which are too fundamental to solve the problems that we're going to look at in the coming classes. Okay. Um, Now, what we're going to be starting off with, we're going to be starting off with absolute fundamentals in terms of trigonometry. Okay. So, what is a triangle, which is so fundamental for our understanding of trigonometry? Now, a triangle is basically a geometric entity which can be formed using three non-collinear points in space. Okay. So, what are these three non-collinear points? What did I say? It is not just any 3 points in space, it is three non-collinear points. That means 3 points which are not on the same line. If were they on the same line, then you can have a probably a straight line, but you cannot have a triangle. Now, given that explanation, so you're gonna have a line going from here to there, and here to there. Now that forms a triangle. Now, what are the aspects of triangle that we have? Now, common aspects of a triangle that you have are basically the side lengths. One is the side lengths definition, and the other one that you have are the angles inside the triangles. Okay. Now, the angles inside the triangle. Now, these are two types. One is interior angles, and the other one is exterior angles, right? Exterior angles. Now, if I say interior angles, if I denote all the in blue and denote all the exterior angles in black, then I would write these interior angles as here and here and here, and the exterior angles are over there, and over here. So these are the exterior angles that we have. Okay. So if you like me to give an arrow mark over there, I can give it to you. So one is here, the other one over there, and the other one over there. So right, okay, wonderful. So now we are going to be also looking at how do we actually write down the names of these triangles. If I give the names as A and B and C as the triangles, so the side lengths are then obviously going to be one is going to be AB and BC and CA. Okay. Now, these are the sides of a triangle. So, sides of a triangle will have a length associated with it because it is a line, and therefore side lengths exist for a triangle. And triangle having three lines have three side lengths. So, one is AB, BC, and CA. Now, in terms of the interior angles, we are not going to be working with exterior angles right now. So, we are only focusing on interior angles of a triangle. Now these are here. Okay, so one is this, and the other one is that, and the other one is three. Now there are three there are three angles. So one is, and two is there, and three is here. So one, two, and three. So how do I write the angle one? Angle one is basically written as angle BAC, and angle two, and this is also equivalent to angle right CAB. Okay, it doesn't really matter whether you go from here till there or go from the other side to this side. Okay, so what matters is what is at the center, which is BAC or CAB. Now the center one remains the same, so they both are pretty much the same angle. So I'm not going to read down or even retain the other one because it's going to lead to confusions. And the other one that you have here for angle 2 is angle B must be the center. So therefore I can write this as ABC. And for the 3, C must be at the center. I can write this as ACB. Okay, so there are three angles that we have. Now for the angles in terms of trigonometry, the symbol that we use for denoting the angle is theta. Okay, now I'm going to write it down here. So theta is the angle, okay, which we shall use to represent the angle. So it is a Greek alphabet, is means angle. Okay, now and then the what is the symbol of degrees? Degrees is the angles. Now there are 360 degrees in at a point over in a circle, or at about a point from its line, and as long as the line starts to rotate and come back to its original position, you're going to have 360 degrees. Anyway, so that's not important. Now you have interior angles, which are three angles over there, and therefore you have three sides. Okay. Now if I look at AB for a moment, if I look at, let's have a look at ABAC. Okay, now BAC is right there, BAC. So that's the angle BAC that I have there. BAC is right there. Now, if I draw a line, a dotted line, and put an arrow mark over there, now where do you think this arrow mark is going to go and hit? This is going to go and hit the angle or the line BC. So therefore, if I look at BC, and if I make another column over there and make this into a table, that is the angle and that is the opposite side. Okay, now if I call that as opposite side. Now, the opposite side for BAC is then going to be, if I draw this arrow and then extend it, it's going to hit the BC line. So for BC is going to be the line opposite to angle BAC. Okay. Now, in the same way, if I look at ABC, and make an arrow and it comes and hits at AC, then AC would be the opposite side. And if I have a look at BCA and start an arrow from there, it's going to go and hit AB. So therefore, AB is going to be the opposite side for our angle ACB. Okay, so that's the perspective. All right. So now, and then one more thing that you have here is that you have the adjacent sides. Okay, so only one opposite side will be there, and they're going to be have two adjacent sides. Adjacent sides. Okay, what are the adjacent sides that we have? And now for BC has already become the opposite side. So in which case, the other two are for us AB and AC. AB and AC are going to be the opposite side or the adjacent sides, right? Now, for the case of angle ABC, you have angle A, B, and C. So AB and BC are going to be the adjacent sides. Anything other than the AC is going to be AB and BC. So that is the angle that we are looking at, which is angle ABC. So angle ABC has directly two lines which are connected to that. One is this and the other one is this. Therefore, these two lines got to be the adjacent sides. Now, if you have a look at ACB, the opposite angle is over there. So other angles here and there. So it is going to be BC and AC. So BC and AC are then going to be the adjacent sides for us. Okay. Now, depending on these, the way in which the angles are presented and things like that, so you can have a triangle of four types. Okay. So let's have a look at what they are. Now, the first one that we're going to have is pretty simple. When you have a triangle and I say that all the angles are equal to each other, all the angles are equal to each other, then it is going to be, or in other words, if all the sides are also equivalent to each other, then I would say that this is an equilateral triangle. Okay, that is an equilateral triangle. Okay, now do not use this symbol when you're writing your exams. Write triangle. Okay, now when you have another triangle like that over here, and two sides are being equal, but that's a side which is not equal to the other side, so this is obviously an isosceles triangle. Okay, that's an isosceles triangle. And when you have a triangle where none of the sides are equivalent to each other, then I say that this is a scalene triangle. Okay, now we have a special case right now. A special case being, now if I have an angle which is 90 degrees. Okay, so this is what we call as a right angle triangle. Now that's what we call as right angle triangle. If, for example, if I say that that is the angle of interest and I call that angle as theta, the opposite side is over there. So that is going to be the opposite side, because if I take an arrow over there and extend it, it's going to meet over there. So that's going to become the opposite side. The other side here is going to be the adjacent side. According to these definitions of all the other triangles that we looked at, so this is also adjacent side. But the speciality of right angle triangle is we do not call it as an adjacent side, but rather we call it by a different name. It is going to be an hypotenuse. Okay. Now, you have already understood so many things about triangles. One is the hypotenuse, and the adjacent side and the opposite side are, which are very important for us to take it forward in terms of trigonometry. Okay, so we're going to use this and build upon our concept based on these things. So we're going to go to the next slide and have a look. What do we have here to learn? We now have Pythagoras theorem, which is essentially geometric relationship. So what do I mean by a geometric relationship? Okay, so if in my family, there are three people: myself, my wife, and my daughter. Okay, now the relationships are very well defined. To my wife, my daughter is daughter and I am the husband. to me, my wife is my wife, and her daughter is also my daughter, and my daughter is also her daughter. And in the same way, to my daughter, we both are parents. I am the father, and she is the mother. Okay. Now, we have a clear relationship, which is a family relationship. In the same way, we also have a relationship when it comes to geometric objects. A triangle is a geometric object, and a Pythagoras theorem is also as a triangle. Now, sorry, a right angle triangle is a triangle. Now, let's have a look at this triangle over here. So, I'm going to call this angle as 90 degrees. That is 90 degrees. And if I, for the moment, say that this is going to be theta, and that is going to be A, B, and C. We already know that this is the hypotenuse, that is the adjacent, and that is the opposite side. Now, what does this Pythagoras theorem say? Pythagoras theorem say is that it basically establishes or exposes an underlying relationship between the sides of the length of the or the sides of the or the lengths of the sides of the triangle. Okay. So now, what are the lengths of the sides of the triangle? One is you have AB, and the other one you have BC, and obviously you also have something called as AC. Okay. Now, if I express the Pythagoras theorem, that means that if you make this into a sort of like a triangle, okay, like okay, in the analogy that I gave you right now, father, wife, and daughter. So if you can say that that's the father, mother, and the daughter. Okay, they are all related to each other. Now, Pythagoras theorem comes and says that if your triangle is a right angle triangle and you have hypotenuse, adjacent, and opposite sides like this, therefore then you can establish a relationship between them. So what is that relationship? It is very simple. If you take the opposite squared and square it, okay, and then you take the adjacent side, and then what you want to do is you want to square it. But then you also take hypotenuse square, uh, but then you see that both of them are equal. So this is the geometric relationship which is brought about by the Pythagoras theorem in a right angle triangle. Now, if I were to rewrite these in terms of the sides of the triangle, opposite side for us is BC. So BC squared plus, if I have adjacent squared, adjacent is going to be AB squared. So AB squared, and this is then going to be AC squared. Okay, people use both of these formula to remember the Pythagoras theorem, but this is what I would advise highly and recommend that this is the one which you should be using it. Because if I were to change, I have seen many students making the mistake, if so many students making the same mistake here. Now, what they do is, if the question says that this is X, Y, and Z, and then they forget, and then they start applying this formula, they forget and they lose track of what they're doing. Do not do that. You should be, if you should be able to position and understand what is the opposite, adjacent, and hypotenuse of square, and then take it forward from there on. So that's how you should actually be doing this. Okay. Now, in the next step, you have already seen what is the hypotenuse and what is the adjacent and opposite side. Now, you have a look at this one over there, and I can also re-express this in terms of hypotenuse, isn't it? Hypotenuse is then going to be square root of opposite squared, and then you also have adjacent squared. All right. Now, in the same way, you can also re-express based on your things that you have learned from your algebra. You can also find out what is opposite. Opposite the squared is then going to be square root of hypotenuse squared minus adjacent squared. It's all pretty simple to see, and I'll be in. If you have any doubts on this, you should refer back to your courses or on algebra or simplification techniques. Okay, or how do you express, or how do you make the subject of one variable in an equation? Okay, now in terms of ratios of a triangles, okay, now when you have a triangle, once again I would like to rewrite this. So that is the angle, hypotenuse and opposite and adjacent. Now, because there are three sides, I can have six ratios which are possible. That means I can expect to have opposite divided by adjacent side. Let's first find hypotenuse. Okay, opposite by hypotenuse is one possibility, and another possibility that I have here is, instead of there, I'm going to call adjacent divided by hypotenuse. Okay, now I'm going to also take the reverse of it. Okay, the reverse of it is also perfectly valid, and the reverse of the other one is also perfectly valid. Now what I do is I take another ratio over there, which is, let's take something like this. Okay, opposite divided by adjacent, and the other one that I'm going to take is adjacent divided by opposite. Okay, so now there are particular names for these. So this is called as sine theta. Okay, that is called as this ratio. I mean, this entire ratio has a name. Okay, now if I were to write it a bit more legibly for everybody, so this over here is called as sine theta. So this ratio is called as cos theta, and this ratio is called as tan theta. Okay, so but the other ones are not in your curriculum. Okay, not in curriculum. But in some schools, if they do expand on these things, do not be surprised to know that they all also have names. So this is 1 divided by sine theta. In other words, it is called as cosecant theta. And this for us is then going to become secant theta. And that here is called as cot theta. Now the full names, okay, now your sine is actually a full name for sine theta, and cos theta, and this is not in your curriculum as well, and I see. Okay, now this is cosine theta, and tan theta is a short form of tangent. Okay, and then you also have cosec theta, which is cosecant theta, and then you have sec theta, which is secant theta, which is secant theta, and then you have cot theta, which is the cotangent. Okay, cotangent theta. So now only things that you really need to remember are these three over there, and you don't have to worry a lot about the other ones. Okay, so these three, so these two and the other one, so one is here and the other two over there. Now given these two ratios, given these three ratios, if I call this ratio as ratio 1, ratio 2, and ratio 3, ratio 3 and 2 and 1 are basically sine theta is opposite divided by adjacent side. So that's your first important ratio that I have. And cos theta is then going to be did I do a mistake? This is hypotenuse. Okay, so sine theta is opposite by hypotenuse, and cos theta is adjacent divided by hypotenuse, and you also have tan theta, which is um, opposite divided by adjacent side. Okay, so opposite divided by adjacent, that's your tan theta. You can also re-express your tan theta as pretty simply as sine theta by cos theta. And how do you get this? It should not be understood, not be a great thing to understand, or I mean get difficulty in understanding this, because you already know about ratios. That I leave that to you to figure it out. Why is tan theta sine theta by cos theta when tan theta is opposite by adjacent? Okay, now when you join to my classes, you're going to be teaching all these things in absolute detail. Okay, and fundamentals will be broken down into it nuts and bolts, and you don't have any doubts or any clarifications which are further necessary. But then during my classes has an advantage where you have direct access to my resources, and at the same time you can ask me any question that you want to have, answered in these topics. But at the same time you're going to have detailed feedback, how you are performing in your classes. At the same time you are going to have mock exams and mock sessions, all under one roof. Okay, now let's go forward and then have a look at basic trigonometric terminologies. Now we have already seen these basic trigonometric terminologies. The only thing that I'm going to be doing here is write them down explicitly. The one is sine theta, and the other one is cos theta, and the other one is tan theta. Now sine theta is opposite by hypotenuse, and cos theta is adjacent divided by hypotenuse, and tan theta is opposite divided by adjacent side. In other words, sine theta divided by cos theta. Okay, so you got to remember this to understand how we go from understanding a triangle towards solving questions in exams which are which are related to trigonometry. Okay, now going to next slide. What are the different types of exam questions that you can get? Okay, now you can get a question on something like, okay, calculate the size of a missing angle. Okay, that is something which is possible, though it is not completely based on trigonometry. You can still use trigonometry to calculate side angles under circumstances where you cannot calculate using properties of angles in a triangle. Okay, now the other one that you can get is calculating, how do you calculate the size of a missing length? Okay, now that is also pretty simple in terms of when you use trigonometry. In most of the cases you can use Pythagoras theorem to solve your problem, but in some cases you will need other ratios, trigonometric ratios, to solve this problem. So I'm going to be teaching all of them in the classes. Now, because these are revision sessions, I'm going to be a bit faster, because I'm assuming that you have already done these uh, you know sort of understanding, and you already have this conceptual understanding beforehand, and then we can take these things even much more farther, and much more slower and more condensed manner in the classes. In the regular classes, I've already provided you the QR code at the beginning, and it's going to be coming up with the next slide as well. Register for it. At this moment, it's going to be a very simple Google form that I have created. Don't be alarmed, just submit in. Your data is safe. I'm not going to be doing it anything with the data. Okay, if at all I'm going to do anything, is probably send an email or a text message to the numbers that you're going to give, or the email address. So it's going to be parents only should be registering, or parents only should be responding to these QR codes, because um, maybe of mobile access issues and GDPRs. So I'm not going to go into those directions. Now, other one that we have here is a combination of both of the above. Now, which is pretty simple, and we're going to be having a look at all these. Okay, how do I? Yeah, right. Okay, how do I take this ruler off? I don't. Okay, fine. Okay, then so these two are done, and questions which build upon these two are basically, which require you to calculate the angle, and also which require you to calculate the length of the sides, right? And you have graphs of trigonometric ratios. Unfortunately, it is not going to be so easy to cover in one session on the graphs of trigonometric ratios. I'm going to be doing it in another session for you, but in the class it's going to be a detailed session anyway, right? And yeah, basically what you're going to see is how the um, um, graphs of sine theta and cos theta and tan theta. So you're going to be looking at the graphs of all these three, and the values of standard angles. Standard angles are angle 0 degrees, 30 degrees, okay, and 45 degrees, 60 degrees, and 90 degrees. So we're going to be learning, so what is this angle sine theta at the values of theta is equals to all these values. Okay, what is the value of cos theta when theta is equals to 45? I'll give you a value which is going to be cos 45 is going to be is equals to 1 divided by square root of 2. People also write it different ways, but in any case, you should not be able to have any difficulty in understanding what these values are once we cover them in greater detail. Now, for final slide, I would like to say that the next session is then going to be on. We're going to be solving a couple of problems in higher trigonometry, or GCSE higher trigonometry, and here's the QR code. You can use this, scan it in your mobile phones to register and give the details on the on the Google form. Mind you, that is just a Google form for the moment, and we're going to be upskilling it later on as we go forward. But the data is going to be absolutely safe. All right. So now, and the other one that we have here is that we also have revision sessions and regular classes going on for GCSE mathematics, both for year 10 and year 11 separately. And there is another session where you also have year 11, where it's inclusive of all the things that you have already done in year 10. That's going to be sort of like a fast track approach. And then you have I also offer classes on year 9 mathematics, okay, including the pre-GCSE preparations. Okay, now for GCSE, I also offer classes for physics on higher. uh, and year 8 mathematics are also being offered. Now at the same time, we're also working on on 11 plus grammar school entrance examinations. Okay, now this is especially interesting, where the kids get to mentally recognize how to solve problems, okay, using nothing but the ability of their minds, right? We'd not encourage them to write it down on a sheet of paper, because on when especially when they are preparing for 11 plus grammar school, because it's going to be mostly sort of a mental math sort of an approach, and we will train your kid in the same approach, right? And you also have the non-verbal aptitude, where you have pattern matching and pick the odd pattern out, and those sort of questions, or the nets problems or the cube problems sort of things. We also give in-depth training as to recognize what patterns are you looking at, and which one is the right pattern for a given question. Okay, now we do unfortunately have an eligibility requirement. Okay, but it must be presently or expected, okay, and above or equal to grade point number 7. Okay, it can either be grade point 7 or grade point 8 or grade point 9, and either in terms of you're currently at that level, or your propose or the predicted scores must be at these values, right? Now what are the advantages that you're going to have? You're going to have regular feedback from the teacher, okay, and you also have customized support in terms of one-on-one sessions with the parents and the kids, and we also have mocks, and we cater to all the exam boards. Okay, now do register, and I'm eager to start the classes as soon as possible. And the tentative dates for starting these classes are this month, which is the next weekend. And we do offer early bird registration goodies. You can find that on the registration form. Do register, and I'll see you soon.